Hi my dear friends, welcome back to our render setup workshop. My name is Hussein Mashayikhi and I hope that you are all doing well wherever you are. Well, this is the fourth session of our workshop and it will be focused on the method of irradiance map. Now in the previous sessions we talked about how with vray renderer we have two different engines, one called primary engine, the other called the secondary engine, and with the help of these two engines we calculate the behavior of light and the light rays that are cast into our scene, and that way we process the scene and we can just get our renders. So we already talked about the brute force method in the previous session and we learned about how that works. In this session and the next we're going to learn about the light cache method and also the irradiance map method. Now let's talk about the differences that we have between the brute force method that we learned in the previous session and also the irradiance map method that we're going to learn right now. Alright, we said that the brute force method, like its name suggests, will distribute the rays of light into our scene evenly, and it doesn't really care what part of the scene is more complicated than the rest, and it will just cast the rays into the scene equally all over. And I gave you an example about how if we want to know the population of a country, we need to send more people to the more dense and crowded cities rather than the small villages. But with the brute force method, they would just like send equal number of people to big cities and small villages. So this is where the irradiance map method comes in, and the irradiance map is kind of like smart, and it realizes what part of the scene is more complicated, like these areas, and it will send out more rays there, but the parts like the wall that are not really complicated and are like flat surfaces will receive less rays of light. And so on the whole, the irradiance map method is both quicker and also more intelligent when it comes to sending out the rays of light into the scene and also giving out our render. Okay, so the brute force method didn't care, just send out rays like a madman all over the place, but the irradiance map method will just take a look at how complicated a piece of our scene is and send out the right number of rays there accordingly. Alright, so we just introduced the irradiance map method and we understood how this method works and how different it is to the brute force method. And now it's time to learn about another difference that we have with the irradiance map method compared to the brute force method, and that is that with this method we have more control over how this method works. So basically with the brute force method we had no control over how many rays are sent over to the whole image, and with this method, the irradiance map method, we have some control. So let me just give you a quick example here. So let's say that we have an image which is 1400 in width and 2100 in height. Okay, so we have exactly 2,940,000 pixels in this image. If we were using the brute force method, we would have 2,940,000 rays cast into the whole image, and we could say that we would have one ray per each pixel. Okay, but if we decide to choose the irradiance map method, we could have some control in terms of the number of rays that are cast into the scene regardless of the dimensions. For example, the irradiance map method could just divide the width by 2 and also the height by 2, and then we would have 1/4 of the rays that we had before. Okay, so we would have 735,000 rays that are cast into the scene. Basically, we would have one ray of light for each 4 pixels, but like we said before, the irradiance map method does not just cast rays evenly and equally. It will decide what parts of the scene are more complicated and will dedicate more rays of light there. Okay, but you get the idea. So we could have less rays cast into the scene, and we could just cut short the time that our render takes greatly. So it's a very useful control that the irradiance map lets us have. Okay, so as you can see, I just gave you an example where we could just divide the width and height by 2, and we could have 1/4 of the rays that we would have for each pixel. Okay, now with this example we talked about how we can just reduce the number of rays that are sent into the image and having less number of rays per pixel. But what about the opposite? What if we want to send out more rays of light into the scene per pixel? For example, we want to have 2 rays of light per each pixel, or 4. That is very possible as well with the irradiance map method. Let's say we have the same dimensions, but this time we want to multiply the pixels in the width by 2 and also the pixels in the height by 2, and we want to have 4 times the amount of rays that we would have per pixel. Okay, so we can just do that. We can just make irradiance map work harder and send out more rays and give us a better render. Alright, so being able to control the amount of rays that we want to cast into the scene is a huge advantage that we would have if we were to use the irradiance map method over the brute force method. And now it's time to see some of what we talked about in action. Alright, we're going to take some renders with the irradiance map method used and select different parameters for it and compare the renders we take right now with the renders that we took last time with the brute force method. They took about 1 hour roughly. So I'm going to go to the render setup, to the GI tab, and choose the irradiance map method as my primary engine method. And as we do that, we get some parameters and setting for our irradiance map, and we're not gonna do anything about this right now. Later on I will tell you about the parameters that you should use for your test renders and final renders, and the only thing that I want you to do right now is to just put the current preset on very low for this render that we want to take right now. And later on I will explain all of these presets and which ones we should use based on the purpose of our render. Okay, so irradiance map chosen as our primary engine. Secondary engine is on light cache. The rest of the parameters are the same. It's gonna send out rays into our scene in a very intelligent way, and it will do everything automatically. The only thing that we did now is to just put the current preset on very low. Later on I will explain all of these different presets and how we can just work with these parameters. Okay, so let's just start with this render. I'm going to click on render and let's see what quality we get and how long it takes. The brute force ones took 1 hour roughly, and let's see how long it takes for our irradiance map render to finish. We already said that it's supposed to take a lot less, and let's just check out the quality as well. Okay, so this render just got finished. It took 31 minutes. So roughly half the time it took for the brute force method to finish the render. Now it's time to check out the quality. So I'm gonna do an A and B. A is the irradiance map render and B is the brute force render. And you can see that we don't have much of a difference. So it took half the time, but it just gave us the same quality. Now, if we look very closely, we can see that the brute force method actually does a better job regarding some of the reflections and also the shadows here, for example inside the plant or with the tables. But we gotta remind ourselves that irradiance map method took half the time it took for the brute force method to finish, and it gave us kind of the same quality. So we can just neglect the differences because it took a considerably less time for the irradiance map method to finish. Okay, and we also put the current preset on very low. And also we should remember that we just took a final render that took half an hour. So if we were to take a couple of test renders, they would take a lot less time with this irradiance map method, and that's a very desirable thing for a 3D artist. Alright, let's go ahead and talk about the irradiance map parameters that we have here. So let's start with the current preset. What do these presets mean and how do they work? So basically we said that the irradiance map method sends out rays into the scene and collects data samples regarding the light. Now with each one of these different presets we can just determine how precise the sample collection process should be. For example, when we put it on very low, we're not going to collect that many samples and we're going to have a certain quality that is not going to be that high. But if you put it on very high, we're going to collect a lot of samples and consequently have a relatively higher quality render, but in a very longer time. So don't forget about the time factor. Let me give you a little demonstration. So what I'm going to do next is I'm gonna go to the global switches, and I'm gonna assign an override material to the whole scene. So I'm going to assign this material here, number 26. I'm gonna change the color to a grayish color, and I'm gonna assign it to the whole scene. Okay, now we're going to change the preset to custom. So I'm going to choose custom here, and for min rate I'm going to put 0, and for max rate I'm also going to put 0. Okay, so there is no numbers in between, and in a couple of minutes you're going to learn how these min rate and max rate work. But for now, let's just say that we put them both at 0, and if we put the preset on very low, we're going to get -4 and -3, and we're going to have different min and max rates for different presets. That's the point. So we just put the preset on custom, and we changed both of the min and max rate to 0. Okay, so 0 for both, and the size of our render is 140 for width and 800 for our height. Okay, so right now the minimum and the maximum rate is not at work, and the only thing that just determines how many rays we get into the scene is the size, which is 1400 and 800. Let's take the render and see how long it takes. It's got to finish rather quickly, and I can see that just it's trying to process the scene, and the pre-passes are at work. Okay, it finished. It took 3 minutes and 23 seconds. Okay, so this is what we get with those parameters. If I divide the width and height by 2, for example, I put 700 for my width and 400 for my height, and keep the minimum and maximum rate at 0 again, let's see what happens. What should happen is that the time of render should be at least divided by half. It's got to be even less than that, maybe a quarter. So this one took 3 minutes. Let's see how long this new render takes. Okay, so I think it should not take any longer than 60 seconds. Right now the rays are sent into the scene, and the data collection or the sample collection process is at work. The pre-passes are getting finished, and in a couple of seconds we're going to get the render. Okay, so this one took 53 seconds. Okay, almost a quarter. All right, so what happens if I cut these dimensions by half again? 350 for width and 200 for height. Even less time, right? It's got to be around 20 seconds. Let's see. It's got to finish rather quickly, because we divided our original size by 4 this time, and remember that the minimum and the maximum rate are still at 0, so they are not affecting the number of rays or the samples that we get. Okay, it took 18 seconds. Okay, again, so we went from 3 minutes to 53 seconds to 18 seconds, and each time we divided the height and width by 2. So basically what I wanted you to understand is that the size of the render matters in terms of the number of rays that are sent into the scene, and also the time it takes to finish the render. Now, the minimum and the maximum rate here kind of works similarly to what we just manually did. We each time cut the width and height by half. That's how these rates work, and that's why I gave you that little demonstration. So if I put -1 for minimum rate and -1 for maximum rate, what's going to happen here is that our width and height is going to be divided by 2, and this new size will be factored in when the irradiance map method is trying to cast rays into the scene. It's going to be like the first 2 renders that we took. The first one took 3 minutes. The second one, when we divided the height and width by 2, it took 53 seconds. So each time that we decrease the value of minimum and maximum rate by 1, our size of the render is going to be divided by 2 in both its width and height, and that's going to determine the number of rays that is cast into the scene, and also the quality of the render and the time it takes to finish the render. So basically this is how the minimum and maximum rate works, and I wanted to do it manually a couple of times so that you could just see it with that demonstration and really understand how these rates work. Okay, so now for example, if I put -4 for both min and max rates, although my original size is 1400 in 800, still it would be as if that size is divided by 2 4 times. Okay, so we're gonna get there under any second now because it's not gonna take that long. And there, it took 1 minute, and as you can see, the size is still 1400 in 800 compared with this one, which took 3 minutes and 23 seconds. So that's how minimum and maximum rates work. And basically with -4 for both of them, it means that if I go back to my width, for example, 1400 is once divided by 2, which is 700, and then again the same thing, 350 and 175, and that's basically how these numbers work. Okay, so I think now you have a pretty good understanding of the minimum and the maximum rate, and you can see why although we have the same size for both of these renders, the time it took for both of them to finish is so much different. Okay, so let's do something different now. Let's keep the min rate at -4 and change the max rate to -3. What happens now? Now we would have two sample collection processes. In one, it would consider -4 as the rate, and in the other, it would consider -3 as the rate. And after both of them are completed, we're gonna have our render. So let's take a render now, and obviously it's gonna take a little bit longer. So we have two pre-passes, as you can see, and now our render is ready. And similarly, if we put -2 here for max rate, we're gonna have three pre-passes, three processes happening. Once for -4 there, once for -3, and finally one other time for -2, and then we're gonna have the render. Okay, so if I put -1, again 4 processes, -4, -3, -2, and -1, and each pre-pass or process would collect the lighting samples with a different precision. Okay, so this time we would have 4 different pre-passes to be completed before we get our render. Okay, and this is the last one, 4 out of 4, and after this one is completed, we'll get our render. So basically this is how these numbers work. And if I put 0 for my max rate, again 1 for -4, 1 for -3, 1 for -2, 1 for -1, and 1 for 0. And when it's for 0, it's gonna be the original size. Now what would happen if I put 1 here? Well, with 1 or a positive number, we're going to have twice the dimension. So each time we have a positive number, minimum and maximum rate of 1, for example, we're going to have twice the size of our width and height. So for example, for our width, we would have 2800, and that would be considered when trying to cast out rays into the scene. Okay, so with a positive number, with 1 for example, we're going to have twice the size of our original render. So basically with negative numbers, each time our size is divided by 2, and with positive numbers, each time it will be multiplied by 2. So I just took a render with the minimum and maximum rate of 1. This time it's gonna take longer. Okay, it took 9 minutes. So again, the original size, but twice the size when casting out rays. Okay, so if I increase this number in the positive direction, each time it's gonna be multiplied by 2, and it's gonna take a lot longer. Now, we compare the time, with different minimum and maximum rates. Let's compare the quality. So the last one that took 9 minutes used a minimum and maximum rate of 1. Let's call it A. And the right side of the image, which is B, is with minimum and maximum rate of 0. Okay, so we can see that there are some differences in some areas more than the others, but the differences are really negligible, and I can't emphasize this enough. It took a lot less time to get the render. So let's just compare this render with the minimum and maximum rate of 1 with the one that we use with the very low preset. this one. So with B, we have the very low preset. Let's compare that. This time the differences are more noticeable, especially regarding the shadows and some of the lines. But again, if we compare the time, the differences are not that big, but let's draw some conclusions. If you don't have enough time and if you want to just take out some renders and hand them out to somebody, put the preset at very low or low and just get it over with. But if you have the time, put the preset at high and enjoy the added quality. So what I usually do is that for my test renders I use very low, and for my final renders I use high. And that's pretty much what I do in terms of changing my presets. So let's just, before we move on, recap how these presets work. So if I put it on high, for example, minimum rate is -3 and the maximum rate is 0. So here in the first prepass with -3, we would divide the original size, which is this one, by 2 3 times. In the prepass of -2, we would divide this size by 2 times, and in the prepass of -1, we would divide this original size by 2 once, and in the prepass of 0, we would use the original size and we wouldn't divide or multiply anything. Okay, so it's time to move on now. I think you understood these concepts pretty handily. The next parameter that I want to talk about is called subdivs or subdivisions. And to explain that to you, I'm going to use an image that I used in the previous sessions. Let's go back to that image and I will tell you what this number refers to. Okay, so let's just do a little flashback to this image here. We said that we have a source of light, we have an object, and we have this camera. Now the camera casts some rays into the scene. They hit a surface eventually, and when they do, they'll bounce around in different directions, and you can see that with these blue arrows here. Okay, so with the number of subdivisions, we control how many of these blue arrows we want to calculate. Okay, so we use a square root number in that subdivisions box, and then that will be multiplied by itself. So the number that we put in that box will be to the power of 2, and that number will be used. For example, if we put 50, 2500 will be used for the number of bounces that we want to have calculations for. Okay, so this is how we can control the number of subdivisions and basically follow some of these bounces that we have in the scene. So let's just do a couple of demonstrations now. If I put 1 for my subdivs and put the preset on very low, I'm going to use the same size and the same setting. I'm going to take a render, and after the render is finished, we're going to compare the time, we're going to compare the quality and everything. Okay, so I just used 1 subdivisions, and let's see how long it takes. I think it's got to be finished now. So let me just delete some of these previous renders so that they wouldn't confuse us. Okay, so it took 1 minute. All right, so let me just delete these. We don't need them anymore. This one took 1 minute, and you can see that the quality has diminished vastly, and just this quality is not really acceptable. So what happens if I put a number like, let's say a bigger number, something like 100? Okay, so we said this number is going to be multiplied by itself, so it's going to be 10,000 subdivision calculations that we're going to have this time. And let's compare the quality and the time it takes to finish. So we said if we put 1 for subdivisions, only 1 bounce will be calculated, but if we put a bigger number like 100 there, that number will be multiplied by itself, so 10,000 different subdivisions will be calculated there. So our second render just got finished, again roughly 1 minute, but this time the quality is a lot better. So let me just compare this for you. A, or the one on the left, is this new render with 100 subdivisions, and B, or the one on the right, is only using 1 subdivision. Okay, so there's a big difference here. Let me just show you. See how much different the quality is. So the time is the same, just 1 minute, but the quality is a lot better. So obviously if you were not using an override MTL, it would take longer, but let's just conclude. If you want to take test renders, 10 subdivisions will do just fine, and if you want to take final renders, a value like 64 would be fine. Okay, so let's just move on. The next parameter that we want to discuss is interpolation samples, and the way it works is that we are sending out rays in different places to collect data and samples, right? And if you wanted to take samples from each single point in the scene, we would need to take like 1 billion samples. So for the places that we do not collect samples from, we use interpolation samples, which is basically an average of the adjacent samples. Okay, so that's what interpolation samples do for us. If I put 1 here and take a render with the same parameters and the setting that we used before, we're gonna have some dark spots and a very low quality render in a second, and you're gonna see really quickly how bad the render gets. You see these dark spots here? They have been created because we are using a very low value for our interpolation sample. So if we increase that, we're gonna get rid of some of these dark patches here on the render. Okay, so each time you were taking a render and you saw those dark spots, the first thing that you should do is to just change these interpolation sample number to a higher one and see if they still persist. So make note of the interpolation sample number when you are taking multiple renders and check the quality until you are happy with the results. So what I'm going to do now is to just take 2 different renders, one with the value of 5 for my interpolation sample, and after that is finished, I'm going to take another render with the value of for example 20 for my interpolation sample, and after they are both finished, we're going to compare them for quality and also the time it takes for them to finish. Now remember, only increase the number of interpolation samples if you are witnessing dark patches or dark spots in your render, because otherwise it may mess up your render in terms of quality and also increase your render time for no reason. Alright, so let's just check out to see if these renders are about to finish so that we can just finally compare them and see if we could get rid of more dark spots in the render by increasing the interpolation sample number. Okay, so we used the value of 5 for one of them and we used the value of 20 for the other. They're, I think, pretty much ready. A couple of more seconds and we'll get to it there. We have A and B. Okay, so let me just move this line, and if we pay attention to the corners, maybe here, you can see that we have reduced the amount of dark patches that we have here a little bit, but it's still noticeable, and it's just working. So basically, if we had used a bigger number than 20, maybe the differences would be more noticeable, but you get the idea. We usually get these dark spots in the walls and in the corners on the floor. Okay, so we talked about the interpolation samples as well, and we're pretty much done in terms of the parameters that we wanted to discuss for irradiance map. And we don't really need to discuss every little parameter and detail that we have here, and the reason is that we're not going to use it, or we're not going to even change it. For example, this detail enhancement option here that we have, if we enable this feature, we're going to have sharper details in our render, but it's going to take a ridiculously longer time for our render to finish, so we never use it. And that's basically why we don't discuss all the parameters here, because we're not going to change any of them, and we talked about the most important ones that are useful for us. So in the next session, we're going to focus on the light cache method. And if you wanted to conclude what we've learned so far, is that when we wanted to take a high quality final render, we put the primary and the secondary engine on brute force, and we go to the noise threshold and maybe decrease the value to something like 0.001. Now, if we wanted to take a test render, we choose the irradiance map method for our primary engine and we put the preset on very low. We also use a number like 20 for our subdivisions, and that will do. If you wanted to take final renders with the irradiance map, we can use 64 or 128 for our subdivisions. So that's basically what we've learned so far, and in future videos we'll learn more about features like the image sampler and the items that are there. So for the next video, we're going to focus on the light cache method and learn about that. And that's pretty much it for this session. I hope that you enjoyed it and that you learned a lot, and I will see you in the next one.